So for example, in this figure, or the definition of a reflection is a transformation that represents a flip of a preimage. It flips a preimage over some line. Okay? So in this figure, where would be my line of reflection here? Yeah, just that horizontal through there, right? That's a line of reflection because I could flip those and they would land right on top of theirs. That's a line of reflection. Okay? Reflections, okay, just like translations, which we haven't talked about translations yet, we'll come back to that. They preserve distance, angle measure, and collinearity. What that means is when I flip an image, okay, the distance between the points stays the same, the angle measures of all the angles stay the same, and all the points that were collinear are still collinear after I reflect it. That's what this means, to preserve these things. Just because I flipped an image, none of these things changed. Okay? We call these types of congruence transformations an isometry. Okay? So an isometry is a transformation that preserves distance, angle measure, and collinearity. I think that's I think it's the last vocab term on that front page. Okay? We haven't talked about translation yet. Okay? So we had reflection was a transformation representing a flip of a preimage, and isometry is a transformation that preserves distance, angle measure, and collinearity. It means the shape didn't change just because I flipped it. It just changed orientation. Okay? That's what an isometry is. Transformation that preserves those things. Okay? So that's what you need for the vocab. We're going to go through a couple of these first examples on your page there. Okay? Again, I already have the pre-image graphed for you. We are going to graph the image, or what happens after we reflect it. So for example, this should be your example, or no, this isn't, this one first. I want you to visualize all of these shapes are the same, all the pre-image are the same. If I flipped it over this line, I want you to think about which line or which figure would this be, A, B, C, or D. If I flipped it over this line, so if I folded over that line, okay, it's a little difficult to visualize, but it's C. If I fold this over this line, okay, see how C prime, we call this prime with a little apostrophe. We always put the new point, we call it the original point prime, B prime, A prime, D prime. It's just an apostrophe on it. Okay? So C's prime is the same distance away from the line of reflection as C is. D prime is the same distance away from the line of reflection as D is. Okay? If I folded over that line, that's what that would look like. So here's example 1 on your page. It says reflect this image over the x-axis. So I'm going to show you first the really long way to do it, and then once we have these rules, it becomes a little easier. So let me darken my axis a little bit here. I have the y-axis there, the x-axis there. So I'm going to flip it over this line. So I'm going to take this figure and flip it over and put it here. Well, I just need to count for B prime. It looks like B is 1, 2, 3 units above the x-axis. So I need to go 3 units the other way from here. 1, 2, 3. And B prime is going to be, oops, let me go back here. 1, 2, 3. There is B prime. I put the little apostrophe on it. Okay, B prime. Because it's 3 units above, if I flip it over, it's going to be 3 units below. Do the same thing for A prime. It looks like it's 1, 2, 3, 4, 5, 6, 7, 8 units above the x-axis, so I need to go 8 units below, because that's the line I'm folding it over. 1, 2, 3, 4, 5, 6, 7, 8. And C prime is 9 units above the x-axis, so I need to go 9 units below. 8, 9. And then connect those lines. And we can see that looks like that image flipped over the x-axis, right? If I flipped it over, B would land on top of B prime, A would land on top of A prime, C would land on top of C prime. Okay? I folded that over that x-axis. Now, you can do that every time on a line of reflection. You could sit there and count all the points, and it would work when you fold over one of the axes. But we have a rule that happens when we fold over the x-axis. Let's see what that rule is. Some of you already figured this out, but the coordinates of the original point B are -3, 3. What are the coordinates of B prime? -3, -3, right? Let's find the coordinates of A. It's 1, 2, 3, 4, 5, 6, 8. What are the coordinates of A prime? 6, -8. The coordinates of C, -4, -5, -6, and 9. The coordinates of C prime, -6, -9. What's happening when I go from A to A prime, B to B prime, C to C prime?
The Y.
Yeah, just the Y becomes the opposite, right? The Y becomes the opposite. 6 stayed the same, 8 became -8. -3 stayed the same, 3 became -3. -6 stayed the same, 9 became -9. So the rule for flipping over the x-axis is if you have coordinate AB, it then becomes the opposite of A, and B, sorry, I just flipped that around. A stays the same, and it becomes the opposite of B. That's the rule on the top of the page. It asks, what's the rule for flipping over the x-axis? If you have coordinate AB, it then becomes A opposite of B, or A negative B. Okay? That's the rule for flipping over the x-axis. Okay? That goes for all figures. No matter what figure you have, all you have to do is you keep the x-coordinate the same, the y-coordinate becomes its opposite. Okay? That's the rule for flipping over the x-axis. So now, anytime you flip over the x-axis, just change that coordinate. Okay? This coordinate, I know would be 6, -8. If the coordinate was already negative, and you put another negative in front of it, it becomes positive, right? So that's example 1 there on the first reflection. Okay? And it looks something like that. Okay? Let's jump to example 2 here. Example 2 says, flip this line over the line y equals x. Again, the line y equals x, that's the line that goes through all the x values when they equal all the y values. So 1, 1, 2, 2, 3, 3, 4, 4, a line like that. So I want to flip this figure over that line. This one's a lot harder. I can't count the little individual spaces from this line, right? Because it's not a horizontal line or a vertical line. It's a line at an angle. Did anybody get to the rule that happens when you flip over the line y equals x? What happens to the coordinates? Yeah. The coordinates just change, right? If the coordinates of the point were AB, when you flip over the axis, it becomes BA. The coordinates just change spots. The x-coordinate becomes the y-coordinate becomes the x-coordinate. So let's look at this. Let's count what these coordinates are, and let's go ahead and graph this reflection. Let me draw my x and y axis here. So point A is at 2. Is it 210? Is that right? The point A is at 210. So when I flip it over that line, where is it going to be at? Huh? It's at 10, 2. The coordinates just changed. So I go to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. That is A prime. I want you to do the same thing for B and C. So what we get is the coordinate of B here?
4, -4.
-4, 4. So what's going to be the coordinate of B prime? 4, -4, right? You just flip them. C looks like it's at -5, 8. So then I go to 8, -5. One, two, three. That's C prime. There's my figure. And that looks right. It should be the same distance away from my line of reflection as the other one is. See how it works? I fold it over that line. That's where that would match up at. Okay? Again, the rule for the line y equals x is you just flip the coordinates. Okay? You just flip the coordinates. So now you have two rules. One for if it's the x-axis, just the y-coordinate becomes its opposite. One for if it's the line y equals x. Okay? Both coordinates just flip. we have a third one. Okay? There's actually 4 total. Again, it should look like that. Okay? If you reflect over the y-axis. So in this case, my finger is actually on the y-axis. So I'm going to take it, lift it up, and flip it right over. Right? Anybody remember the rule for if you flip over the y-axis? That would have been, I think, the very first one you guys did. A lot of you got to it. What happens to the coordinates when you flip over the y-axis? Yeah, the x-coordinate becomes its opposite, and the y-coordinate stays the same. That's the rule for the y-axis. The x-coordinate becomes its opposite, the y-coordinate stays the same. So let's look at that. Point U. And let me darken up my axis here so you can see them. Point U is 1, 2, 3, 2. So U prime is going to become what? Opposite of the x, leave the y the same. -3, 2. Which that looks right? Because if I just take that shape and I flip it over on that y-axis, okay, there's U prime. All right, then I find R. R is at 2, -1. So that means R prime is going to become -2, -1. S is at -1, -3. S prime is going to be the opposite of x, so +1, -3. Then the same thing for t. It's at -2, 1. So I'm going to go to +2, 1. There's t prime. Connect that figure. So that is that shape. I flipped it over the y-axis. Right? I took it, I flipped it. Yeah, that looks like that's how it would land. Right? If I flipped it, U would land on U prime, R would land on R prime, S on S prime, T on T prime. Okay? This is the rule for the y-axis. Okay? So then we only have one left. Okay? We have if we flip it over the origin. Where's the origin on a graph? 0, 0, right? This is the origin. Okay? So on that last one, again, that's what the shape would look like. You flip it over on the y-axis. On the origin, all you're doing is finding the distance like from R, from the origin to R. You're going the same distance in the opposite direction. So R prime is going to be over here. For U, let's see, it's that distance here, so it would be somewhere down there. Okay, that makes sense. U prime would be down there. R prime would be up there. Okay, T prime would be close to where original R is. The rule we have for the origin. Does anybody know the rule for the origin? If you have AB, what happens when you flip it through the origin? Yeah.
Both become their opposite?
They both become the opposite. That you would get the new coordinates would be the opposite of A and the opposite of B. Okay? So like this R is at 2, -1. So the new coordinates would be -2, +1 for R prime. We're actually going to finish this problem next time because I want to talk about this week's assignments.